Hello everyone, welcome back. Welcome to Sri Chaitanya Academy YouTube channel. So I welcome you back to this lecture of transition course. In this transition course, basically we are bridging the gap from class 10th to class 11th. And in this course, right, we have done so many things. We have done functions, quadratic equations, straight lines, trigonometry, differentiation, integration. And now we are doing the last part of this transition course, that is the vectors. Okay, so those of you who have joined new or are new to this channel, please do go to the playlist section and watch all the video in line, right? If you watch all the videos, you will have a better understanding of this physics part, right? And what is the base. Okay, basically this course is for strengthening the base of your physics. Okay, so without further ado, let's start with vectors. Okay, so in the last class I did talk about what scalars and vectors are. So let me tell you again that what are scalars. Okay, so anything that has only magnitude. Okay, so what do you mean by magnitude? Some number associated with it. Okay, some number associated with it. So let's say for an example, let's say that the time right now is 5 o'clock, right? So let's say the time, okay, the time is 5, right? The time is 5 o'clock, right? So now what does that mean? That what is the magnitude here? What is the magnitude? The number associated with it is 5, right? So what is magnitude? Magnitude is the number associated with the quantity. Okay, magnitude is the number associated with the quantity, right? So let's say number of runs, right? Let's say Virat Kohli scores some runs. So Virat Kohli, right? The runs scored, let's say he scores 54 runs, right? So 54 runs means this is the number, okay? This is the number associated with the quantity, correct? So that is what scalar quantity means. But now when we come to the vectors part, right? What is this? This is vectors. And what are vectors? Vectors are something which has a number associated with it plus some direction. Okay, so physical quantities which has some magnitude, okay, some number associated, some number, right, and a direction associated with it, So now how to understand this? Let's suppose if I am standing on this end of the board, right, and then I tell you that okay, walk 2 steps, right, walk 2 steps. Now when I say walk 2 steps, what do I mean? Right, either I can move forward 2 steps, either I can move backward 2 steps, towards right, towards left, right, any direction I can move 2 steps. But if I say okay, walk 2 steps towards left, so when I say walk 2 steps towards left, right, basically I am telling you how much steps? 2 steps. And what is the direction? Towards left. Okay, so in that scenario I am also talking about some number and also talking about some direction. Okay, so what is a vector quantity? Vector quantity is something in which I specify number, that is the magnitude, and I also specify direction, right? As I told you, go to left or towards right. Now what is this follower vector algebra? Okay, so we'll talk about this vector algebra, okay, as we move on to this chapter. Okay, but for now on, simple thing is that, right, what is the simple thing? Simple thing is, what is a vector? Something which is associated with magnitude plus direction. Okay, what is vector? Vector is magnitude plus direction, simple as that. Okay, so if I have magnitude and direction, I will say that this is a vector quantity. Now so let's do one question. It is given that pick out the only vector quantity from the following list, right? So this is a list, okay, and I have to choose which is a vector quantity and which is a scalar quantity. Okay, so let's talk about this first, work, right? So what is work? Okay, work is something we do, no, right? Like I will say that okay, I have done 8 hours of work today, okay, or we can also specify in terms of hours, right, that for 8 hours I was continuously working, or for 4 hours I will continuously studying. But work, right, in your lower standard you might have heard about work, and work is a scalar quantity because see, work doesn't need direction, that I was doing so much amount of work in this direction or so much amount of work in that direction. Okay, it is a quantity, it is just a number that we define. Okay, so I will say this is a scalar quantity, this is scalar quantity. Mass, right? So what is mass? My mass either is, let's say, 4 kg, 10 kg. Okay, so in physics, mass and weight are two different things. Okay, what I will say, mass is not equal to weight in physics. Okay, right? Usually we say that, okay, what is your mass or what is your weight, right? We say that they both are the same thing usually. Okay, but in physics, mass and weight are not the same thing. But here, if you ask me, right, what is the mass, I will say 50 kg, 60 kg. No, so that is a number associated with it, but there is no direction associated with it. So this is also a scalar quantity. Okay, now this is electric potential. Okay, so potential 5-volt battery, 6-volt battery. No, we say that bring a 5-volt battery or bring a 10-volt battery. So now this battery is, okay, or the potential, okay, that is a scalar quantity. Correct. Now what is acceleration? Okay, so acceleration, right, in your lower standard you might know that acceleration forces mass into acceleration. Correct. So now you understand that if there is a force acting on the body, there will be some acceleration acting on the body, right? So if I take this pen and if I throw this pen in this direction, right, it will accelerate in this direction. Yes or no? Correct. If you are going on a bike, yeah, and you you roll the accelerator, what will happen? You will move forward, no? Correct. But if you apply the brakes, you will stop, okay, or your speed will decrease, right? So the same thing, what is happening, that in the direction in which you are applying force, there is some acceleration. Okay, and acceleration is also, so acceleration in this direction or this direction, right? That will make sense. So I can say this is a vector quantity. Okay, so this is the vector quantity. Okay, this is the vector quantity. Now speed. Okay, so now what is speed, right? If you look in the car, no, there is a speedometer. In your bike, right, or Activa or a car, there is a speedometer which tells you that, okay, your car is moving at a 20 km/h speed, 40 km/h speed, or 100 km/h speed, right? So it is just telling you the number and what is the speed of the car. But does it tell you that where it is going? Does it tell you that it is going towards east, west, north, south? No, it doesn't tell you, right? So that is just talking about the magnitude of the number itself, right? So this is also a scalar quantity. Okay, this is a scalar quantity. So what is the vector? Okay, we will talk about velocity. We will talk about velocity later in this chapter, and this velocity is basically speed plus direction. Okay, it is speed plus direction. Okay, so this is a vector quantity. What is velocity? Velocity is speed plus direction, and we will talk about this later in the chapters. Then energy. Okay, energy or work is usually associated. Okay, so this is also a scalar quantity, that I have this much amount of energy, right? Correct. I don't say that I have this much amount of energy in that direction. Okay, then is density. What is density? Density is mass per unit volume. How much mass, right, I have in a cubic 1 cubic volume. Correct. So centimeter cube volume or 1 meter cube volume. So this is also a scalar quantity, and temperature is also associated with a number. That temperature is 30 degrees centigrade, 20 degrees centigrade, or 0 degrees centigrade, right? So this is the number which we have. Correct. So out of this is my acceleration, and acceleration is a vector quantity. So I hope now you can define that what is a scalar quantity, what is a vector quantity, and how you can identify which quantity is which. So now let's talk about the representation of a vector. Okay, so now if I want to represent a vector, okay, how will I represent a vector? So let's say if I want to talk about mass, no? So what is mass? Let's say mass is 10 kg, simple. Mass is 10 kg, right? I can say 10 kg, or let's suppose if I want to represent in gram, what can I say? 10 into 1, 2, 3, right? Grams. Yes or no? Because 1 kg is how much? 1 kg is 1000 grams. So now I can represent this like this. But what about a vector? What about a vector? A vector is associated with a magnitude, right? In a scalar quantity, I have written the magnitude. But what about the direction for a vector quantity? Okay, so for a vector quantity, if it is, so what do we need? We need magnitude, right? And magnitude is represented by modulus of A, right? This function, these two parallel lines, these two parallel vertical lines are known as the modulus function. Okay, this is other known as the modulus function, right? So let's say if I tell you that okay, I am walking 2 steps forward, or I am walking 2 steps towards left, or 2 steps toward right, right? What is the magnitude of steps I have walked? 2 steps, correct? So example, right? If I walk, let's say 2 meters towards left or right, what will I say? I will say that the magnitude of steps. What is the magnitude? Magnitude is the number. Okay, and here what are the number? 2 steps, right? So 2 steps towards right and 2 steps towards left, correct? But now how do I identify that in which direction, right? In which direction I have walked, right? So now understand that if I am standing here and I say please walk 2 steps towards right, right? So how will I say? I will say 2 steps towards right. So this is how I will tell, right? So this arrow tells me the direction in which I have to move. Okay, this arrow is telling me that okay, go towards right. Okay, go towards right. For you the right is this one, right? So go towards right. And how many steps? 2 steps, right? But for some other person whom I am telling that okay, go 2 steps towards left, right? So 2 steps towards left. So this is how I will say that okay, 2 steps, but where? In the left direction, correct? Now tell me, if I want to tell that okay, walk 3 steps towards left. If I tell this, okay, walk 3 steps towards left. So now you understand, no? So if this is 2 steps, 3 steps will be somewhere here, right? So this arrow tells me the direction, right? And the length of this, right? I repeat, the length of this, okay, arrow will tell me that what is the magnitude which I want to walk. Okay, so now let's come back here. The length of the arrow is directly proportional to the magnitude of this vector. Okay, so what the quantity or the number which is defined is given by the length of this vector, and the direction is given by the arrow here. Okay, so what is a vector quantity? Vector quantity is something, right, which has direction as well as magnitude. So this arrow will help me with the direction, and the length of this vector will help me with the magnitude. Okay, and how do I represent a vector quantity, right? So a vector quantity, let's suppose acceleration, if I want to say, no, so acceleration is a vector quantity. I will say A, right? Okay, this is a number A, this is a quantity variable A, and A is acceleration, and with the arrow at the top, that will tell me that okay, A is a quantity which is a vector. Okay, let's suppose velocity. So I will say velocity is V, and with an arrow at the top. So what do I understand? V is a vector quantity. But only if I write V, then V is a scalar quantity. Okay, so that is the way how you differentiate between a scalar quantity and a vector quantity. Now, angle between two vectors, right? So now I know that what is a vector quantity? Vector quantity which has something, a direction as well as magnitude. And how do I represent that? I represent that by an arrow. Okay, the length of the arrow tells me the magnitude, okay, that what the quantity is, right? So let's suppose if this pen has a length of 5 centimeters, okay, if this length of this pen is 5 centimeters, then if I say that okay, what a pen of 10 centimeters length will be something like this, correct? So the magnitude is increased to 2. So similar way, the length of the vector will also increase to 2. Now when we talk about angle between two vectors, okay, so angle between two vectors, right? How do you find the angle between two vectors? The smallest angle between two vectors when joined tail to tail or head to head, right? So what do I need? First of all, I need two vectors. What I am calculating here? I am calculating the angle between the two vectors which I have here. Okay, so A is one vector and B is of the other vector. So what do you do, right? You take your first vector. Okay, so let's say A is my vector 1. Okay, A is my, this is vector, and B is also a vector, and B is also a vector, correct? So now what do you do, right? This is now, what is this known as? Okay, so this part of my vector is known as the tail of the vector, and this part is known as the head of the vector, right? What is the tail? This part is known as the tail of the vector, and this part is known as the head of the vector. So now what do? You take this vector and you shift it and you bring it here, right? So what can I do? I can shift this vector and I can bring it here and I can join both the tails of this vector. Correct? What did I tell you? That, okay, so let's write it here, that you can shift a vector parallel to itself okay, I can shift a vector parallel to itself. So let's understand, okay. So if I am keeping a vector, so let's suppose this pen is a vector, okay. This pen is a vector with the arrow at this point and this is the tail, okay. This is the head, this is the tail, okay. So let's suppose if I am keeping a vector at this point, right, if I shift it, right, I can shift it like this. I can shift it like this and I can bring it here, right. Yes or no? So you understand that the direction has not changed, right. It is still pointing in that direction, right, and the length of this vector has also not changed, okay. If I shift this vector parallel to itself, okay, if I shift this vector parallel to itself anywhere, okay, even if I shift it here, right, nothing happens to this vector, because see, the direction is still same and the magnitude is still same wherever I shift this vector but parallel to itself, okay, clear. So you should understand that if I, okay, now from here to here you understand, okay, this is parallel, but is this parallel to itself? Yes, correct. This vector, and if I take this vector here, both the vectors are parallel to itself, okay. So shifting a vector parallel to itself doesn't change the vector, okay. So what is allowed? You can shift a vector parallel to itself, okay. So now once I shift this vector, right, what I am trying to do, I will join this tail, I will join both the tails here, right, and there are two angles between them. Let's understand what are the two angles. This is first angle, right, this is theta angle, and this is the other angle, okay. This is the other angle which I have, let's say this is phi, right. There is one theta and other is angle phi, right, and can I say that theta plus phi should be equal to how much? 360 degrees. Theta plus phi should be equal to 360 degrees, okay. Now what is this theta? This theta is the small angle, right, and this phi is the big angle. Yes or no? If let's say if this is 60, this will be 300, correct. So now what I will do, I will only take the small angle between them, right. So the smallest angle, okay, so the smallest angle between the two vectors when joined tail to tail, or head to head, okay, we forget about this head to head, okay, first focus on tail to tail, right. If I join the vectors tail to tail, right, the small angle between them is known as the angle between the vectors, okay. So I hope you understand how to calculate the angle between the two vectors. So now let's understand, okay, let's solve one question, okay. Let's move on to this type of vectors. So what are equal vectors? Okay, as the name suggests, what are equal vectors? Vectors which have equal magnitude, okay, vectors which have equal magnitude. But now, is vector only made up of magnitude? No, vector has magnitude as well as direction, okay. So here both the quantities should match, okay. So since vector, I'll write since vector is made up of magnitude and direction, right, both quantity should be equal, right, both quantity should be equal so that they can be called equal, correct. So vector is made up of magnitude and direction, and both quantities should be equal so that they can be called equal vectors, okay. So same magnitude and direction. So if you look here, right, this is A vector, this is B vector, okay, and length of both the vectors, right, this is how I will measure the, like, bring a scale and you will measure the length of the vector, right, and you measure the length of this B vector, right. You can see that both are of same length, and direction also is same. Similarly, these two vectors, right, they both are parallel to each other, yes or no, correct? So both of them have the same direction and same length. So these type of vectors are known as equal vectors. Second, we have negative vectors, right, as the name suggests, right, negative vector. So what is negative of left, right, what is negative of up, down, right? So now here, since it is a vector, right, what are the two quantities, what are the two factors which we have? The magnitude as well as direction. Now you understand the negative is associated with the direction part, okay? The negative means opposite direction, okay? Negative means, I will say, opposite direction, right? Or I can say vectors which have opposite direction, okay? Equal vectors, but magnitude should be equal, okay? So same magnitude but opposite in direction, okay? So if this is telling walk 2 meters towards left, this vector is telling us walk 2 meters towards right, okay? So this is the difference between the, this is what is negative vector is. Null vector, null means zero vector, okay? Null means zero vector. So now what is zero? Zero is basically telling me the direct magnitude of this vector, correct? So zero or null magnitude or sorry, zero or null magnitude and undefined or arbitrary direction, right? So now what do you mean by that, right? So when I say that a vector, let's say this is my vector A, okay, and the vector A is 0, right? If 0 is there, what do you mean by that? That length of the vector is 0, correct? Length of the vector is 0. Now if I want to make a vector with length 0, right, can I say this is the vector? Why? Because this dot is a vector. Why? Because see, if you want to measure the length of this vector, this will come out to be 0, yes or no, correct? So now how will you make the arrow here? In which direction will you make the arrow? I cannot make the arrow, no, correct? Because the vector doesn't exist at all. So null or zero magnitude vector, right, which have like arbitrary direction. Arbitrary means any random direction, okay? So we have any random direction, okay, clear? Now, so velocity of a car at rest, okay? An example is a velocity of a car at rest, right? So if a car is standing, let's suppose if I am standing here, okay, what is my speed? 0, right? So if there is speed 0, right, what is velocity? Speed plus direction. Speed is 0, right? So the vector quantity will also be a 0 vector. Parallel vectors, vectors having same direction, okay? Vectors having same direction. So if vector is in, let's suppose if I tell you that, okay, walk 2 meters towards left, so 1 and 2 meters towards left, correct? But what if I tell you walk 3 meters towards left, so 1, 2 and 3, right? So I have walked 3 meters towards left. In both the cases, right, in which direction I was moving? Towards left, okay? What was different here? The magnitude was different, okay? For first it was 2 units, for second vector it was 3 units, okay? So I have a difference of the magnitude, but the direction is same, okay? So what I will say, vectors having same direction, okay? Magnitude can be different, cannot be different, not necessary, okay? Equal vectors are also parallel vectors, no? If I have two vectors, let's say I have one vector like this, let's say this is 2 and I have other vectors this 2, correct? So are they equal vectors? Yes, they are equal vectors, right? They are equal vectors. Are they parallel vectors? Yes, they are parallel vectors, correct? So what can I say? Equal vectors are parallel vectors. Equal vectors are parallel vectors. Next, anti-parallel vectors. What do you mean by anti-parallel? Means that the vectors will have opposite direction, correct? So having opposite direction, what about the magnitude? We don't care about the magnitude. It can be equal, it cannot be equal, it doesn't matter, okay? What matters? That anti-parallel vectors should have opposite direction. Second, coplanar vectors, okay? So vectors lying in the same plane, okay? When I say vectors are lying in the same plane, right? Now first of all you should understand what do you mean by a plane, okay? So let's draw a diagram, okay? Now, so Now understand here, what is this? Okay, this is kind of a box, or let's understand this is the room in which you are sitting. Okay, you are sitting inside a room and watching this video. Let's understand this is the room in which you are sitting. Correct? Now you do one thing, you focus on any one of the corner. Let's suppose you focus on any one of the corner. Correct? So I focus on any one of the corner. Okay, now you understand that what is this basically? This is basically the x-axis. This is one of the axis x. This is one of the axis, and this is the y-axis which we have, and this is the z-axis which we have. Correct? So if you understand, if I am on one corner of the room, this is my x-axis, this is my y-axis, and the axis which is pointing outwards, right, or the axis which is pointing towards you is the z-axis. Correct? Now understand, then how many, so we are talking about planes, no? We are talking about planes. So now you understand, if you are sitting in this room, if you are sitting in your room, right, how many planes do you see? How many planes do you see? So if you count the number of planes, right, how many walls I have? One wall, right, second wall, third wall, and a wall behind me. Correct? I have 4 walls in this, right, and I have a wall at the top and I have a wall at the bottom. Okay, this is floor. Correct? So I have how many walls? Total 6 walls. Yes or no? I have 6 walls, and these 6 walls are my 6 different planes. Okay, in this 6 walls I have 6 different planes. Correct? So what are the planes? The planes are x, y, right? Correct? So now you understand, or no? This is first plane, okay, second plane, third plane, and my fourth plane, fifth plane, and the sixth plane. Okay, so now how do you understand that this C, x, y, and z, x, y, and z. Okay, so I have how many planes? I have 6 planes, but let's understand. So if it is made with x and y axis, right? If I talk about this plane, right? What is this? This is made with x and y. So this is xy plane, right? If you talk about this plane, right? This plane has y axis and z axis. This is yz plane, and this plane, okay, the floor which I am talking is what? xz plane, xz plane. Okay, so now what are coplanar vectors? Vectors, co means same. What do you mean by co? Co means same, right? So same plane, vectors which lie in the same plane are known as coplanar vectors, right? So if I have one vector on this and this other vector, can I say they both are coplanar vectors? Because they both are lying on the floor. Let's say if I have this vector, right, and if I have this vector, are these two vectors coplanar? Are these two vectors coplanar? No, they are not coplanar, because one vector is lying here and the other vector is lying here. Yes or no? So these two vectors are not coplanar. Okay, these two vectors are not coplanar. So you have to understand, okay, when two vectors are coplanar and not. Next, unit vectors. Okay, so this is the most important thing, okay, in physics. This is the very important concept, correct? And usually students, right, are not able to understand this. I don't know why, but please pay attention. Okay, we'll understand this in very easy way. We'll understand this in very easy way. Okay, so what is this unit vector? Unit means 1. What do you mean by unit? Unit means 1. Okay, so unit means 1. So a vector having magnitude 1. First of all, what is unit vector? Having magnitude equal to 1. First of all, unit vector is a vector having magnitude 1. Now, used to represent the direction of the vector. Now, it is used to represent the direction of the vector. What do you mean by that? We will come back to that in a minute. Okay, and how do you represent this vector? This represent this vector by a, but not with the arrow. It is represented by a hat. Okay, this is known as a hat because it is looking like a hat, right? And what is mod a? Mod a is equal to 1 by, because I know that the magnitude of a unit vector is equal to 1, that is why a 1 is written here. Okay, this is okay, but now what unit vector is actually? So let's understand a unit vector. So let's suppose I am asked a question, I am told to go towards in this direction, okay, go towards this direction, okay, how many units? 2 units. Let's say I walk in this direction 2 units, correct? I walk in this direction 2 units. Now I am asked to walk in this direction, right? how many, let's say 5 units. So what I'll do, I will draw an arrow, right, 5 units, correct? But now let's suppose if I am asked to go in this direction by 1 unit, right, by 1 unit. So I will draw an arrow and write this is 1 unit, correct? But now if I tell you that okay, if I want to write this, now if I write this 2 units, right, in this way, that this is my 1 unit and this is my 1 unit. Can I say this is 1 unit and this is my same 1 unit, right? So what do I have? I have 2 units towards the left direction. No, I have 2 units to the left direction. What can I do here? I can say 1, 2, 3, 4 and 5 units, right? 5 units towards the left direction. So now what is this unit is made up of? What is this 5 unit made up of? I can say this is made up of 5 arrows. No, it is made up of 1 unit 5 times. What can I say? What is this 5 units? I can write that this 5 unit is 1 unit into 5. Correct? What is this 2 units? 2 unit is, right? I can say 2 units is 1 unit into 2. Yes or no? But let's suppose if I want to say that okay, I want to go in that direction 100 units. I want to go in this direction, but how many? 100 units. So what can I say? I will say that if you want to go in this direction 100 units, I will say 100 units. 100 units is equal to 1 unit. How many times? 100 times. Correct? So what is the quantity which is constant in each of them? This 1 unit, no? This 1 unit quantity is constant in each of them. 1 unit here, this 1 unit, this 1 unit, right? So now what is this? This 1 unit is the fundamental quantity. Basically this 1 unit is basically giving me the direction in which I have to go, right? And what is this? This is basically the magnitude. This is basically the magnitude, if you understand. Correct? So similarly a unit vector. What is a unit vector? A unit vector is a vector which is basically telling me about the direction in which I have to go, right? And so now understand, right? So any vector if I want to write, let's say, so what is this made up of? So I can say this is a unit vector and this is the magnitude. So any vector if I want to write, any a vector if I want to write, right? What is it is made up of? It is made up of the direction, right? It is made up of the direction, and that direction is given by the unit vector which I have. Into what is this 5? This 5 is the magnitude of that vector, right? This 5 is the magnitude of this vector, and that is mod A. Correct? So any unit vector can be written as unit vector into the magnitude of this direction. Any vector, right, can be written as the magnitude into unit vector. Okay, so from this what do you get? Unit vector. If I cross multiply this, I will get unit vector is vector A upon the magnitude of this vector. Clear? So I hope you understand what a unit vector is. Okay, and this concept is very important. Clear? Because later on you will see. Okay, later on I will give you a vector, right, and I will tell you to find the unit vector of that. Clear? And through that I will be able to find another vector, right? How? Because see, understand, from this 2 unit vector, this vector, I can find the unit vector, and from this unit vector I am able to find a unit vector, a different vector. Yes or no? So this is later on you will understand, but for this, for now you understand what unit vector is. Okay, operations of a vector. So now we'll move on to the operations. Okay, so now we have finished the types of vectors, right? And now we are moving to the operations part. So operations of a vector. So first is multiplication of a vector by a real number. Okay, so let's suppose if I have a vector and if I multiply it by a real number, right? So multiplying a vector A by a positive scalar lambda, right? What do I have? A positive scalar quantity, okay, a positive number, right? And if I multiply it by a positive number, it changes its magnitude by a factor lambda while its direction remains the same, right? So it is the same thing, no? That if I have a vector, right, and if I am multiplying it by a quantity lambda here, this is the lambda quantity, what is happening? The direction is remaining the same, only the length or the magnitude of the vector is changing. Okay, so this is the same thing, that if I have a vector here A, correct, and if I multiply it by some quantity 2, right, so what will happen? The direction will remain same and only the length of this vector will change. So A will become 2A. So the direction remains the same, right, but the magnitude will become lambda into A. Clear? Next. So now A is multiplied by 2. Let's suppose I have A, right? So let's say A is a vector. Okay, and if A is multiplied by 2, what will happen? I will get a vector which is of twice the length. Let's suppose if A is multiplied by minus 1. So let's say if this is A, right, what do you think minus A vector will become? Right, a minus A vector will be a vector in opposite direction, and this will be minus A. Clear? Now, a vector is multiplied by minus 1.5. So, if this is vector A, correct, minus means minus 1.5, right? So, I will have a vector minus 1.5A, right? So, this will become a vector, right, in opposite direction, because what will happen? What is minus A? Minus A is a vector opposite to vector A, right? This is the negative vector. So, this vector will be equal to basically how much? 1.5 is the magnitude, and minus A basically is telling a vector which is in opposite direction to this vector. Okay, minus A is a vector opposite to the direction of vector A. Next, vector addition and subtraction. Okay, so for vector addition, okay, there is a triangle law and a parallelogram law of vectors. Okay, so first we will talk about this law and then we will talk about the polygon law, right? So the triangle law and the parallelogram law, they both are basically same only, okay, but in different ways. So we will study both of them and finally we will come to the polygon law. Okay, so let's start. So triangle law of vectors, it states that if two vectors are acting simultaneously at a point are represented by two sides of a triangle. Okay, so this is the point, right? Two sides of the triangle taken in same order, then the resultant is represented by the third side of the triangle taken in opposite sense. Correct? So this is my first vector, this is my vector A. Okay, this is the vector A which I am talking about, and this is the vector B which I am talking about. What do I have? I have vector A and I have vector B, right? Then so what is the order? This is the order, right? I am going from here to here, right? Let's say this is P, this is Q, and this is R, right? So if I am going from P to Q and Q to R, right, what is my resultant? My resultant is an arrow drawn from P to R. Okay, how can you understand? Again, let's read the statement. It states that two vectors acting simultaneously at a point, right, are represented by the two sides of a triangle taken in same order. Okay, they are represented by two sides of a triangle. So a triangle have 1, 2. These are the two sides of my triangle. Okay, and the third side of the triangle will basically represent my the resultant of the triangle. Okay, so let's understand again that let's suppose this is my vector A, right? This is my vector A, and let's say this is some vector B. Okay, this is some vector B. Okay, and let's say the angle between them is theta. Correct? This is a vector A, this is the vector B, and there is some angle theta. Correct? So now what I am doing here, what I am trying to do is that I know that I can shift my vector parallel to itself, right? I can shift my vector parallel to itself. So if I take this vector, and if I shift it here, right, I can draw the vector here, right? So can I say that this vector, if I shift it here, this vector B will come here? Yes or no? And since this is theta, can I say this vector will also make an theta angle with this horizontal? Yes or no? So now, since this is theta, this is also theta, and what is my resultant? Right? What is my resultant basically? So the resultant of my vector is given from this, right? This is my P, this is my Q, and this is my R point. So just join these 2 points. Okay, so basically I am removing this. So what will happen? I will basically come to this part, right? And here I can say that this is my resultant R. Okay, this is my resultant vector R. Okay, this resultant vector R and this R point is not same. Okay, What is this? This is some vector r, and this is just the name I have given to this edge or this corner. Clear? Next. So now what is parallelogram law? Okay, we know what is triangle law. Triangle law is that if I have two sides of a triangle, the third side is basically the resultant of the, basically it is the resultant, right? Now, what is parallelogram law? It states that if two vectors acting simultaneously at a point, simultaneously means they are acting together, okay, right? If two vectors, so what are the two vectors? This A is my vector 1 and this is my other vector B, right? And they are simultaneously acting at this point. What is this point? This is the point where they are acting, right? So at a point is represented in magnitude and direction by the adjacent sides of a parallelogram. Okay, so the two vectors are basically representing the two sides of the parallelogram. Clear? So this is my first side of the parallelogram and this is the second side of the parallelogram, and they both are adjacent, right? Then their resultant is represented by the diagonal of the parallelogram, right? What is this? Then the resultant is basically the diagonal of the parallelogram, and this is the diagonal which I have. So what if I want to repeat again? I have two vectors, and the two vectors are basically the two adjacent side of the parallelogram. So vector A, vector B, these are the two adjacent sides of the parallelogram. Then the resultant is basically the diagonal of the parallelogram for this same point. Correct? So what can I say? R is equal to A plus B. The resultant of these two vectors A and B is given as A square plus B square plus 2AB cos theta. Okay, and this is called law of cosines, and we know that this cos theta is between -1 and 1. Clear? But okay, this is the law, this is the formula. Okay, here also we got R as A plus B. Okay, here what we are saying that the two sides of the triangle are A and B, then the resultant is the third side. Here we are saying that if the two sides of the parallelogram are A and B, then the diagonal is the resultant. But now how do we come to this formula? How will we come to this formula? Because what I have to do, I have to use this formula in my questions, no? Eventually I will be using this formula in my question. So let's try to understand this formula. Okay, so first of all, let's go back to this parallelogram law. So I have my first vector A and I have this other vector B. So this is my A vector and this is my B vector, and the angle between them is theta. Correct? Now what did I tell you? What can I do? Right? Let me change this color. Right? This is my B vector. Now what I am trying to do, right? I am trying to parallel shift, right? I will do a parallel shift of this vector. So let's do one thing. Let's shift this vector parallel to itself. Okay? So when I bring this B vector here, right? Can I say this B vector will look like this? This B vector will look like this. Yes or no? Correct? Now if this B vector is this, right? What is this angle? This angle will be equal to theta. Yes or no? So now what do I have in this? So let's redraw this. So basically I have my A vector. Okay. What is this? This is my B vector. Correct? And this is angle theta. And what is the resultant? What is the resultant? The resultant is the diagonal, okay, of this parallelogram. The resultant is the diagonal of this parallelogram. Okay. R is basically A plus B. The resultant is A plus B. Yes or no? Or in other words, I can say that if these are the two sides of the triangle, this is the resultant which I have. The third side is the resultant, right? So now you should understand that both the laws are basically the same, right? Written in different way. Correct? But now what I want to do, I want to take this, right? I will draw a perpendicular here. I will draw a perpendicular here. Okay? And just focus on this triangle. What is this triangle? Is, let's say P, Q, R. Just focus on this triangle P, Q, R. So if I take this P, Q, R triangle here, okay, let's draw this P, Q, R triangle. This is theta, correct? And this is B, correct? Let's say this is some x1 length, let's say this is some x1 and this is x2, correct? Now we'll use trigonometry. So what is x2 upon b? Can I say x2 upon b is basically x2 base upon hypotenuse, and that is equal to cos theta. So can I say x2 is equal to b cos theta? Correct? Similarly x1 upon b, is perpendicular upon hypotenuse, that is how much? Sin theta. So I will say x1 is equal to b sin theta. Correct? So now I have the value of x1 and I have the value of x2. So now what I will do, I will take this triangle and I will draw it again, right? So if I draw it again, what do I have? I have something like this. Correct? So what is this length? Just 1 minute. Right? So this is my resultant which I have. Correct? So now what is this? This length is x1. This length is x1. So what is this length? x1. And x1 is equal to how much? b sin theta. What is this length? What is this length? This length is a plus this length, right? This x2. This is my x2 length and this is my x1 length. So can I say this length will become a plus, how much is this? x1 is, this is x2 and x2 is b cos theta. This will become b cos theta, right? And what is this? This is the resultant vector r. But so now what is this? Can I say this is a right angle triangle? And in right angle triangle what holds? Right? Pythagoras theorem. So let's write the Pythagoras theorem. So what is the Pythagoras theorem? R square is equal to b sin theta whole square plus a plus b cos theta whole square. Right? So what do I get here? I get b square sin square theta plus a square plus b square cos square theta, right, plus 2ab cos theta, right? So finally if you understand this, right, b square sin square theta plus b square cos square theta, if you take b square common, what do you have? B square into sin square theta plus cos square theta, that will become 1. So r square will become how much? This will become a square plus b square plus 2ab cos theta. Okay, 2ab cos theta. Clear? And if I remove this root, okay, finally what do I have? I have this under root. There will come into under root and I will have r is basically a square plus b square plus 2ab cos theta. Okay, so this is the formula which I am able to find. R is equal to a square plus b square plus 2ab cos theta. Okay, now you understand what is this? This is the angle, right? This phi, what is this? This is the phi angle that the vector makes with the vector A, right? If this is phi, right, this is phi and this is phi, correct? So in this triangle, what can I say? Tan phi is b sin theta perpendicular, b sin theta upon a plus b cos theta. So what is phi? Phi is the angle made by the resultant with vector A. Clear? So what is tan phi or alpha, right? Tan phi or tan alpha, okay, both are the same thing. Tan phi is b sin theta upon a plus b cos theta. Okay, now how do you get this condition? Okay, this is a homework for you. Please try to solve this. Okay, I will give you a hint. What is the hint? Right, substitute max and minimum value of theta, max and min value of cos theta. Clear? You will get your answer. Okay, so please try to do this homework, but you understand this law is very helpful. Okay, this law, okay, this is my parallelogram law which I converted to triangle law and I solved it. Clear? So both laws are same, right? And what we are trying to do, we are basically trying to find the length of the resultant vector. If I have a and b vector, which are at angle theta. If I have A and B vector and the A and B vector are making angle theta, then this is the resultant angle which I have. Clear? So with this we will end today's session, okay, and we will continue tomorrow. Clear? I hope you enjoyed this session. If you have any doubts, please, okay, there is a QR code, okay, which will be shared in this. Please scan this QR code and please subscribe the channel if you enjoyed it. Okay, we will come with more videos, and I hope we will meet you again tomorrow at same time, 5 o'clock. Okay, thank you everyone. Have a nice day. Bye.
Oh, yeah, yeah.